Now, in this lecture, we will find out the radius of the semicircle. In the drawing, we have triangle ABC. Triangle ABC is a right triangle because angle ABC, this angle equals to 90 degrees. And we know that side AB of triangle ABC equals to 3 units, and side AB also is tangent to the semicircle at point B. The touching point between tangent AB and the semicircle is at point P, and also side AC or the tangent AC is tangent to the circle at point E, or the touching point of tangent AC if this semicircle is at point E. We also know that line segment DC, this line segment equals to 1 unit. Again, line segment AB equals to, or side AB of triangle ABC equals to 3 units, and we want to find out the radius of this semicircle. Okay, so first of all, I will present to you a new rule, rule number 1. Rule number 1 states that the lengths of two tangents from a common external point to a circle are equal. I will repeat on rule number 1 again. Rule number 1 states that the lengths of two tangents from a common external point to a circle are equal. So what is the meaning of rule number 1? The meaning of rule number 1 is actually, if we have this circle and point P, it is actually an external point in relation to this circle because of the fact that point P is not located inside the circle nor on the circle itself, but outside the circle. Therefore, point P is defined as external point in relation to this circle. So if from point P we draw two tangents to this circle, so here this will be the first tangent, and we define the touching point between the first tangent and the circle as point A. And actually the length of this first tangent is PA, and we will draw also the second tangent to this circle from point P, and we will define the touching point between the second tangent to this circle as point B. And as you can see from the drawing, the length of the second tangent is PB, and according to rule number 1, the length of those two tangents to the circle, when you draw the tangents from an external point, that is to say from point P, the lengths are equal to each other. That is to say, PA equals to PB. So I repeat on rule number 2 again, the lengths of two tangents from a common external point to a circle are equal. The length of two tangents from a common external point, actually point P is a common external point, so the length of the two tangents that we drew from point P to the circle, the length of this first tangent is PA, and the length of the second tangent to this circle is PB, and according to rule number 1, the length of those two tangents are equal to each other. That is to say, PA equals to PB. So whenever you draw two tangents to a circle from an external point, then the length of those two tangents will be equal to each other. In this case, PA equals to PB. Okay, so this is the meaning of rule number 1, and we actually can implement rule number 1 in our drawing, because in our drawing we have point A. This point A is an external point in relation to this semicircle, because point A is not located inside the semicircle nor on the semicircle itself. Therefore, point A is defined as an external point of the semicircle. So from point A, we have two tangents to this semicircle. The first tangent is tangent AB, and the second tangent from point A to this semicircle is AE. So according to rule number 1, whenever you draw two tangents to a circle from an external point, then the length of those two tangents will be equal to each other. In this case, according to rule number 1, the length of the first tangent is AB, and AB also equals to 3 units. AB will be equal to AE, because of the fact that the length of two tangents, when you draw it from an external point to a circle, are equal to each other. Therefore, according to rule number 1, the length of the first tangent from point A is AB. The length of the second tangent from point A to this semicircle is AE, and according to rule number 1, the lengths of those two tangents are equal to each other, that is to say AB equals to AE. Okay, AB equals to AE, but we know it is given us in the question that AB equals to 3 units. So we can write here that AB equals to 3 units, and from this equality, 3 equals to AB equals to AE, we can derive that AE also equals to 3 units. AE equals to 3 units. So we can write here that line segment AE equals to 3 units. So we will define the center of this semicircle as point O. I'll repeat again, point O is the center of this semicircle, and I will present to you rule number 2. Rule number 2 states that a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So I will read rule number 2 again. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its point of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is that if you have this circle, suppose that the center of this circle is at point O, and we have a tangent to this circle actually tangent AB is tangent AB is tangent to the black circle at point M. Point M is the touching point between tangent AB and the black circle. Then we will draw radius from point O to point M. So OM is the radius of this black circle. We will define it as R. So if we have a circle and a radius, actually point M is defined as the point of tangency. Point M is the point of tangency of tangent AB with this black circle. So point M is the point of tangency. So if we have a tangent to a circle and a radius that is drawn to the point of tangency, like in this drawing, you can see that this radius is drawn to the point of tangency. That is to say, it is drawn to point M. Then, according to rule number 2, according to rule number 2, the tangent AB is perpendicular to this radius that is drawn to the point of tangency, that is to say, to point M. Okay, so that is to say, this angle is a right angle, it equals to 90 degrees. So angle OMB is a right angle, and angle OMA, it is also a right angle, it equals to 90 degrees. So I'll repeat on rule number 2 again. So whenever we have a radius that is drawn to the point of tangency, like in this drawing, we have radius OM that is drawn to the point of tangency, that is to say, it is drawn to point M. Then the tangent AB will be perpendicular to this radius, that is to say, this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. So that is the meaning of rule number 2, and we actually can implement rule number 2 in our drawing. Because as you can see from the drawing, tangent AC or side AC or tangent AC is tangent to this semicircle at point E. So point E is the point of tangency. And right here, point of tangency of tangent AC with this semicircle. Now we will draw a radius from point O to point E, or we will join points O and E together by a straight line. Actually, OE is the radius of this semicircle because of the fact that line segment OE starts from point O, that is the center of this semicircle, and ends at point E, that is a point on the semicircle itself. Therefore, OE, line segment OE, is defined as the radius of this semicircle. Therefore, I define it as R, that is the radius of this semicircle. So, also from the same reason, you can say that OB is also the radius of this semicircle because of the fact that it starts from point O and ends at point B, that is a point on the semicircle itself. Therefore, OB, line segment OB, is the radius of this semicircle, and from the same reason, also line segment OD is the radius of this semicircle because it starts from point O, that is the center of the semicircle, and ends at point D, that is the point of the semicircle itself. Therefore, OD is the radius of this semicircle. We define it as R. So here, if we focus on the radius OE, actually the radius OE is drawn to the point of tangency, that is to say, the radius OE is drawn to point E, that is the point of tangency of tangent AC with the semicircle. Therefore, according to rule number 1, whenever you have a radius that is drawn to the point of tangency, then the tangent AC will be perpendicular to this radius. That is to say, this angle will be equal to 90 degrees, or angle AEO will be equal to 90 degrees, and angle OEC will be also equal to 90 degrees. because of the fact that the radius OE is drawn to the point of tangency, that is to say, it is drawn to point E, therefore the tangent AC is perpendicular to this radius, that is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. Okay? So, actually, triangle OEB is a right triangle, so we will focus on the right triangle, triangle OEB. I will repeat again, triangle OEB is a right triangle, and we will focus on the right triangle, triangle OEB. Okay? So I'll repeat again that the right triangle, this right triangle, triangle OEB, we'll focus on this right triangle, triangle OEB. In this right triangle, according to the Pythagoras theorem, so according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. And in this right triangle, triangle OEB, the hypotenuse is OC. So according to the Pythagoras theorem, OC square equals to OE square equals to the sum of the squares of the perpendiculars, that is to say, equals to OE square plus EC square. Plus EC square, we will define EC as x, that is to say, EC equals to x units in its size. So, according to the Pythagoras theorem, in the right triangle, triangle OEB, OC square equals to OE square plus EC square. Okay? But what is the length of OC? From the drawing, we can see that OC equals to OD plus DC. That is to say, OC equals to R plus 1. OC equals to R plus 1. So OC square is R plus 1 square. OC square is R plus 1 square. And what is OE? OE is the radius of this semicircle, therefore OE equals to R, and OE square will be equal to R square. So OE square equals to R square plus EC square. What is the size of EC? According to our definition, the size of line segment EC or the side EC is x units, so EC equals to x, and EC square will be equal to x square. So in total, okay, here EC square equals to x square. So in total we got, according to equation number 1, R plus 1 square And according to Pythagoras theorem, r plus 1 square equals to r square plus x square. Here we will open the brackets on this side of equation number 1, and we will get that actually r plus 1 square is r square plus 1 plus 2r, according to the rule that a plus b square equals to a square plus b square plus 2 times ab. So, and it equals to r square plus x square. So in total we got this equation number 1. So here we have r square on this side of equation number 1, and we have r square on the other side of equation number 1. So we'll subtract r square from both sides of the equation. So r square will get cancelled. And what is left after we cancelled r square? After we cancelled r square, we will have this expression 1 plus 2r equals to x square. So we found out that according to equation number 1, 1 plus 2r equals to x square. Okay, so in the next step we will focus on the right big triangle, triangle ABC, this right big triangle, triangle ABC, and we will also focus on the small right triangle, triangle EOC. Okay, so I'll write it down. So we'll focus on the right big triangle, triangle ABC, and the small right triangle, triangle EOC. Okay. I'll repeat again. We will focus on the right big triangle, triangle ABC, and the small right triangle, triangle EOC. So first of all, it is given us in the question that angle ABC equals to 90 degrees, and we have already found out that angle OC, angle OEC, this angle also equals to 90 degrees. So we can write down that angle ABC equals to angle OEC, and both of those two angles are equal to 90 degrees. So I will write it down. Angle ABC is equal to angle OEC, and both those two angles are right angles, they are equal to 90 degrees. Okay, I will repeat again. Angle ABC is equal to angle OEC, and both those two angles are equal to 90 degrees. Okay, they are both right angles. And we also have here angle, this angle is a common angle, it belongs to both triangles. Angle ACB belongs to triangle ABC, and angle ECO, the same angle, also belongs to the small right triangle, triangle EOC. So we can write down that angle ACB, this angle, so we write down that the angle equals to itself. Okay, angle ACB, this angle is equal to angle ECD, it's a common angle because it belongs to both triangles. So I'll repeat again. angle ACB equals to angle ECD. It is a common angle, it belongs to both triangles. So therefore we actually wrote down that the angle equals to itself. Okay, and we also have the third angle on those two triangles, the first pair of angles that are equal to each other. Actually, angle BAC, this angle BAC is equal to angle EOC, this angle. So actually those two angles are also equal to each other. I write it down. Angle BAC, this angle is equal to angle EOC, this angle. So angle BAC equals to angle EOC according to third angle theorem. According to third angle theorem, I will repeat again, angle BAC equals to angle EOC according to the third angle theorem. So actually those two angles are equal to each other according to third angle theorem. So what is the third angle theorem? The third angle theorem is that third angle theorem states, or you can see it as rule number 3, third angle theorem states that according to third angle theorem, if two angles of one triangle are equal, or if two angles of one triangle congruent to two angles of another triangle, I repeat again, if two angles of one triangle congruent or are congruent to two angles of another triangle, then the third pair of angles, the third pair of angles must also congruent. When I say first pair of angles, I actually relate to those two, to the two triangles, of course. So I will repeat on rule number 3 again. Rule number 3 states that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must also congruent. So what is the meaning of the third angle theorem? The meaning of the third angle theorem is that actually if we have two triangles, we have triangle ABC and triangle CDE, and we know that two angles of triangle ABC are equal to two angles of triangle CDE. Suppose that this angle is alpha and this angle is beta in triangle ABC. So here this angle also equals to alpha and this angle equals to beta, exactly like this triangle. So as you can see, in those two triangles they have two angles that are equal to each other. This angle are equal to each other, they are both equal to alpha, and this angle are also equal to each other in both triangles, they are both equal to beta. So according to third angle theorem, the third pair of angles, those two angles will be also equal to each other. And you should remember that in any triangle, the sum of the angles are equal to 180 degrees. Okay, so in triangle ABC, the sum of the angles are equal to 180 degrees. Therefore, alpha plus beta plus gamma, we define this angle as angle gamma, is equal to 180 degrees, according to the rule that in any triangle the sum of the angles are equal to 180 degrees. Okay, and the same rule is true also in this triangle. The sum of the angles in triangle CDE is also equal to 180 degrees. So we'll define the third angle, angle CED, as angle theta, and according to the rule that says that in any triangle the sum of the angles is equal to 180 degrees, we will receive that alpha plus beta plus theta equals to 180 degrees. Okay, so this is equation number 1 and this is equation number 2. What is the size of angle gamma in triangle ABC? The size of angle gamma will be equal to 180 degrees minus alpha plus beta. Okay, angle gamma equals to 180 degrees minus alpha plus beta. We just subtracted from equation number 1 alpha and then beta. We got that angle gamma equals to 180 degrees minus alpha plus beta. And what is the size of angle theta in equation number 2? Again, we will subtract angle theta will be equal 180 degrees. We will subtract alpha and beta from equation number 2, and we will get that angle theta equals to 180 degrees minus alpha plus beta. According to equation number 2, angle theta equals to 180 degrees minus alpha plus beta. Okay, so we actually found out that both angle gamma and angle theta, they are both equals to 180 degrees minus alpha plus beta. Okay, angle gamma equals to 180 degrees minus alpha plus beta, and angle theta also equals to 180 degrees minus alpha plus beta. Okay, they are both equals to 180 degrees minus alpha plus beta. So from this equality we will derive that angle theta equals to angle gamma. That is to say, if we have two angles in one triangle that are equal to two angles in the other triangle, that is to say, those two angles are equal in those two triangles, then the third angle will be also equal, the third pair of angles will be also equal in both triangles. That is to say, angle gamma equals to angle theta, as we have already proved that angle gamma equals to angle theta. Okay, this is the proof of third angle theorem, that whenever we have two triangles that have two angles that are equal to each other, then the third pair of angles must be also equal in both triangles. We proved that angle gamma is equal to angle theta, that is actually the third angle that are equal in both triangles, or the third pair of angles that are also equals in both triangles. Okay, so we actually proved the third angle theorem. Okay, so we actually proved that three angles of triangle ABC are corresponding equal to three angles of the right triangle, triangle EOC. We proved the three angles of triangle ABC, 1, 2, 3, are corresponding equal to three angles of triangle EOC, 1, 2, 3. Okay, therefore, so I'll write it down. Therefore, we proved that triangle ABC, we proved that triangle ABC is similar to triangle OEC. Triangle ABC is similar to triangle EOC. Okay, triangle ABC is similar to triangle EOC according to angle similarity rule. I will repeat again. We actually proved that triangle ABC is similar to triangle EOC according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is that actually if you prove that all three angles of one triangle are correspondingly equal to all three angles of the other triangle, then we proved that those two triangles can similar to each other according to angle similarity rule. So from the fact that triangle ABC is similar to triangle EOC, we will derive the following relationship, or the following relationship exists between the sides of those triangles: AB over AC in triangle ABC, AB side AB of triangle ABC over side AC of triangle ABC, AB over AC equals to side OE of triangle OEC over side OC of triangle OEC. I will repeat again. Because of the fact that the big right triangle, triangle ABC, is similar to triangle OEC, AB over AC equals to OE over OC. Okay? So, what is the value of AB? The value of AB is 3 units, according to what is given us in the question. And what is the value of AC? The value of AC, it is actually equals to 3, AE is 3 plus X. Again, AC equals to 3 plus X. So, I'll repeat again. AB equals to 3 units and AC equals to 3 plus X. And what is the value of OE? OE equals to the radius of the semicircle, so it equals to R. R is the radius of the semicircle according to our definition. And what is the value of OC? The value of OC, it is actually R plus 1. R plus 1. So, in total, we got that according to equation number 2, 3 over 3 plus X equals to R over R plus 1. Here we will cross multiply equation number 2, and we will get that three times R plus 1 equals to R times 3 plus X. We will open the brackets in both sides of equation number 2, and we will get that three R plus 3 equals to 3R plus RX. So here we have 3R in this side of equation number 2, and we have 3R on the other side of equation number 2, so we will subtract 3R from both sides of equation number 2, so 3R will get cancelled. And what is left after we cancel 3R? What is left is actually 3 Rx equals to 3. So we got that Rx equals to 3. We will divide equation number 2 by X. we will divide equation number 2 by x. Why it is allowable to divide equation number 2 by x? Maybe x equals to 0, and then if x equals to 0, it is not allowable to divide by 0. But as you can see in the drawing, x is actually EC, and it is one side of the right triangle, triangle EOC. Therefore, EC must be a positive number. EC that equals to x must be a positive number. Therefore, EC can never be 0. Therefore, it is allowable to divide equation number 2 by x. So we divide equation number 2 by x, and we will get that r equals to 3 over x. We divided equation number 2 by x, and we got r equals to 3 over x. And from equation number 1, we know, according to equation number 1, we know that according to equation number 1, 1 plus 2r equals to x squared. I'll repeat again. According to equation number 1, 1 plus 2r equals to x squared. So we will substitute r in equation number 1 by 3 over x. Okay, because r equals to 3 over x, we will substitute r in equation number 1 by 3 over x. According to equation number 2, r equals to 3 over x, so we will substitute r by 3 over x in equation number 1, and we will get that 1 plus 2r, and r is 3 over x, it equals to x squared. Here 2 times 3 is 6, so we will write it down that 1 plus 6 over x equals to x squared. So here we will multiply equation number 1 by x. I've already explained that it is allowable to multiply the equation by x because x can never be 0. So we multiply equation number 1 by x, and we will get that x plus 6 equals to x squared times x is x cubed. So here we will subtract 6 and then x from equation number 1, and we will get that according to equation number 1, x cubed minus x minus 6 equals to 0. We subtracted x and 6 from equation number 1, and we got that x cubed minus x minus 6 equals to 0. So here x equals to 2 is solution to this equation, because 2 squared is 8. 8 minus 2 is 6, and 6 minus 6 is 0, so x equals to 2 is solution to this equation. So here we will subtract from equation number 1 2x squared, and then we will add 2x squared to equation number 1. So minus 2x squared plus 2x squared is 0, so we change nothing. Therefore, it is allowable to do this operation, because we change nothing. We add 0 to equation number 1. So here x cubed minus 2x squared plus 2x squared is 0. Minus 2x squared plus 2x squared is 0. Therefore, we change nothing by adding 2x squared, and then by subtracting 2x squared. Actually add 0 to equation number 1. It is allowable. Then it is minus x minus 6 equals to 0. Here we will substitute minus x. Minus x equals to minus 3x plus minus 4x plus 3x. Again, minus x equals to minus 4x plus 3x. So we'll substitute minus x in equation number 1 by minus 4x plus 3x, because of the fact that minus 4x plus 3x equals to minus x, we can substitute minus x by minus 4x plus 3x. So we'll do it now. X squared minus 2x squared plus 2x squared. So instead of minus x, we will write down minus 4x plus 3x minus 6 equals to 0. So here we will take a common factor from these two expressions. We will take a common factor of x squared. X squared is a common factor of those two expressions. So what is left after we took x squared as a common factor of these two expressions? Inside the brackets we will have here x, and from this expression, what is left after we took x squared as a common factor, what is left from minus 2x squared is minus 2. Okay, so we took out x squared as a common factor of those two expressions, and we got that x squared, and in the brackets we have x minus 2, and then we will also take a common factor of 2x out of those two expressions. We will take out a common factor of 2x out of those two expressions, and we took a common factor of 2x. So what left from 2x squared after we took a common factor of x? What is left is actually x. And what is left from minus 4x after we took out a common factor of 2x? What is left? It is actually minus 2. Okay? And then we will take a common factor of those two expressions, 3x and minus 6. We will take a common factor of 3 out of those two expressions, 3x and minus 6. So we'll take a common factor of 3 out of these expressions. So what is left after we took a common factor from 3x? What is left inside the brackets is x. And what is left from minus 6 after we took out a common factor of 3? What is left? It is actually minus 2. Okay, and all equals to 0. So we got this expression. As you can see, x squared times x minus 2 plus 2x times x minus 2 plus 3 times x minus 2 equals to 0. Here we'll take a common factor of x minus 2, a common factor of x minus 2 of this expression, and we will get that, so x minus 2 is took out as a common factor of those expression. So inside the brackets, what is left here, if we took x minus 2 out of this expression, inside the brackets what is left is x squared, and what is left after we took x minus 2 as a common factor of this expression, what is left is actually 2x, and what is left after we took x minus 2 as a common factor of this expression, what is left, it is actually 3, and all equals to 0. So we actually got the equation that states that, according to equation number 2, x minus 2 times x squared plus 2x plus 3 equals to 0. So we got this expression, x minus 2 times x squared plus 2x plus 3 equals to 0. Here we will have two possible solutions to this equation. Either x minus 2 will be equal to 0, or x squared plus 2x plus 3 will be equal to 0. Okay? So we write down the two possible solutions to this equation number 2. The first possible solution is that x minus 2 equals to 0, and the second possible solution to this equation number 2 is that x squared plus 2x plus 3 equals to 0. Okay, solution number 2 is actually a quadratic equation, and the general formula of a quadratic equation is actually ax squared plus bx plus c equals to 0. Here a, b and c are the coefficients of this quadratic equation, and x is the variable that we are looking for, and we can find out the value of x according to a special formula. The formula is that x equals to minus b plus minus the root of square root of b squared minus 4 times a times c over 2a. Actually, the expression inside the root is defined as discriminanta. So b squared minus 4 times ac is, we defined it as d, abbreviation for discriminanta, and if the discriminanta is negative, if it is smaller than 0, then there is no solution to this equation, because we don't have a root or a real root for a negative number. Okay? For example, minus 9 is a number, the square root of minus 9, there is no real square root, a real number that equals to the square root of minus 9, because minus 9 is a negative number, and there is no root for a negative number. Okay, actually we know that the square root of minus 9 is 3i, but I is not a real number, it is imaginary number. Therefore, we don't have a real number that is a solution for any for the root of any number. So there is no solution for b squared minus 4 times ac when it is negative. Okay, so if the discriminant of our quadratic equation is less than 0, it is negative, then there will not be any solution to the quadratic equation. And we should also remember that our quadratic equation is x squared plus 2x plus 3 equals to 0, so we search what is the value of x, and in the drawing we can see that x is one side of quadrilateral of the right triangle EOC, and for the reason that x is a side of a triangle, it must be a positive number. Okay, because of the fact that EC that equals to x must be a positive number. Therefore, if we will get that the discriminant is negative, then it means that there is no solution. Okay, so we'll check what is the discriminant of our quadratic equation b squared minus 4 times ac. The discriminant of any quadratic equation, it is actually d equals to b squared minus 4 times a times c, when a, b, and c are the coefficients of the quadratic equation, and our specific quadratic equation is x squared plus 2x plus 3 equals to 0. Here a equals to 1, b equals to 2, and c equals to 3. Okay, so what is the discriminant of our specific quadratic equation? The discriminant is actually b squared minus 4 times a times c, when a, b, and c are given to us. We found out that a equals to 1, b equals to 2, and c equals to 3. So b squared is 2 squared, 2 squared is 4, and minus 4 times a is 1, minus 4 times 1, times c is 3. So in total we got that d, that is b squared minus 4 times ac, is 4 minus 4 times 3 is 12. 4 minus 12 is minus 8. So d equals to minus 8, that is a negative number. And because of the fact that d is a negative number, there is no solution to this quadratic equation, x squared plus 2x plus 3 equals to 0. Therefore, this possibility is not correct, and we left only with the possibility of the solution that x minus 2 equals to 0. And if x minus 2 equals to 0, then x equals to 2 units. So we found out that x equals to 2 units. And according to equation number 1, we know that r times x equals to 3 units. And we have already found out that x equals to 2 units, so we can substitute x in equation number 1 by 2. We'll substitute x by 2, and we will get that r times x is 2 equals to 3. Here we will divide equation number 1 by 2, and we will get that r equals to 3 over 2 units. Or another form to represent it, it equals to 1.3 units. So we actually found out that the radius of this semicircle equals to either 3/2 units or 1.5 units. Okay, I'll repeat again. The radius of this semicircle equals to either 3/2 units or it equals to 1.5 units. So now I'll summarize the lecture. Actually, we wanted to find out the radius of this semicircle, and we have here right triangle ABC, and triangle ABC is a right triangle because of the fact that this angle ABC equals to 90 degrees. We also know that side AB equals to 3 units, line segment DC equals to 1 unit, and we want to find out the radius of this semicircle. Okay, so first of all, I presented to you a new rule, rule number 1. And according to rule number 1, rule number 1 states that the lengths of two tangents from a common external point to a circle are equal. So if we draw two tangents from a common external point to the circle, then the length of those two tangents will be equal to each other. And we actually implemented rule number 1 in our drawing. I'll repeat again on rule number 1. Rule number 1 states that the lengths of two tangents from a common external point to a circle are equal. So according to rule number 1, if we have this circle and point P is external point of this circle, if from point P we will draw two tangents to this circle, tangent PA and tangent PB, then the length of those two tangents that are drawn from an external point P to the circle, the length of those two tangents are equal to each other. That is to say, PA equals to PB. Okay, so we implemented rule number 1 in our drawing. We have in our drawing point A, that is external point to this semicircle, and from point A we have the tangent AB and the tangent AE. According to rule number 1, whenever you draw two tangents from an external point to a circle, then the length of those two tangents will be equal to each other. That is to say, AB will be equal to AE. Okay, AB will be equal to AE according to rule number 1. According to rule number 1, AB equals to AE. But we know that AB equals to 3 units. It is given us in the question. So AB equals to 3 units. So from this equality we can derive that AE also equals to 3 units. Okay, so we can write here that AE equals to 3 units. Then I presented to you rule number 2. According to rule number 2, a tangent to a circle is perpendicular to the radius drawn to its points of tangency. So what is the meaning of rule number 2? The meaning of rule number 2 is this: actually, if we have a circle and the center of this circle is point O, and we have tangent AB is tangent to the black circle at point M. Point M is the point of tangency of tangent AB with this black circle. So whenever you have radius that is drawn to the point of tangency, that is to say it is drawn to point M, then the tangent AB will be perpendicular to this radius. That is to say this angle will be equal to 90 degrees and this angle will be also equal to 90 degrees. I will repeat again. Whenever we have a radius that is drawn to the point of tangency, that is to say in this example it's point M, then the tangent AB will be perpendicular to this radius. That is to say angle OMA will be equal to 90 degrees and the angle OMB will be also equal to 90 degrees. And we actually implemented rule number 2 in our drawing, because in our drawing we have tangent AC is tangent to the semicircle at point E. Point E is the point of tangency of tangent AC with the semicircle, and we have radius OE that is drawn to the point of tangency. Therefore, the tangent AC will be perpendicular to this radius. That is to say, angle OEC, this angle will be equal to 90 degrees, and angle OEA will be also equal to 90 degrees according to rule number 2. So actually, angle OEC equals to 90 degrees according to rule number 2. Therefore, triangle OEC is a right triangle. And in the right triangle, in any right triangle, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars, and the hypotenuse of triangle OEC is OC. So the square of the hypotenuse is OC square equals to the sum of the squares of the perpendiculars equals to OE square plus EC square. So OC square equals to OE square plus EC square. What is the size of OC? The size of OC is R plus 1. OC equals to R plus 1, so OC square is R plus 1 square. What is the size of OE? OE is the radius of the semicircle, so OE is equals to R, and OE square is R square. And what is EC? EC is defined as X. According to our definition, EC equals to X, so EC square will be equal to X square. So in total we got that, according to equation number 1, R plus 1 square equals to R square plus X square. Here we open the brackets in this side of equation number 1, and we got that R plus 1 square equals to R square plus 1 plus 2, and it equals to R square plus X square. We subtracted R square from equation number 1, and we got that 1 plus 2R equals to X square. According to equation number 1, 1 plus 2R equals to X square. Then we focused on two right triangles, the right big triangle, triangle ABC, and we also focused on the right small triangle, triangle OEC. On those two triangles, we have those two angles that are equal to each other. They are both right angles, therefore they are equal to each other. And we have this angle that is a common angle, it belongs to both triangles. So this angle equals to itself. And the third angle, those two angles are also equal to each other according to the third angle theorem. Okay? So we have three angles in triangle ABC that are corresponding equal to three angles of triangle EOC. What is the third angle theorem? The third angle theorem is actually states that if two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles must also congruent. So according to the third angle theorem, if we have two triangles, triangle ABC and triangle CDE, and in those two triangles we have two angles that are equal in both triangles. Here in triangle ABC we have angle alpha and beta, and in triangle CDE we also have the same angles, angle alpha and beta. So we have two angles in those two triangles that are equal to each other. According to the third angle theorem, the third pair of angles, those two angles will be also equal to each other. That is to say, angle gamma will be equal to angle theta. We have, why? Because we have the rule that the sum of the angles in any triangle equals to 180 degrees. the sum of the angles in triangle ABC equals to alpha plus beta plus gamma, and it equals to 180 degrees. So here alpha plus beta plus gamma equals to 180 degrees. If we subtract alpha and beta from equation number 1, we will get that angle gamma equals to 180 degrees minus alpha plus beta. Then we will do the same process in triangle CDE. In triangle CDE also the sum of the angles are equal to 180 degrees. That is to say alpha plus beta plus theta equals to 180 degrees. And if we subtract from equation number 2 alpha plus beta, we will get that angle theta also equals to 180 degrees minus alpha plus beta. So we found out that angle gamma equals to 180 degrees minus alpha plus beta, and angle theta also equals to 180 degrees minus alpha plus beta. From this equality we can derive that angle gamma equals to angle theta. This is the proof of third angle theorem. Okay, we actually proved that that third angle theorem is true. Okay, so we actually proved that three angles of triangle ABC are corresponding equal to three angles of the right small triangle, triangle EOC. Therefore, we actually proved that triangle ABC is similar to triangle OEC according to angle similarity rule. Okay, triangle ABC is similar to triangle EOC according to angle similarity rule. From the fact that triangle ABC is similar to triangle EOC, we will derive that AB over AC equals to OE over OC. AB over AC equals to OE over OC. Okay? AB equals to 3 units, AC equals to 3 over X units, OE equals to R, OC equals to R plus 1. Here we cross multiply the equation number 2, and we got that 3 times R plus 1 equals to R times 3 plus X. Here we opened in equation number 2 the brackets, and we got that 3R plus 3 equals to 3R plus X. We subtracted 3R from equation number 2, and we got that, according to equation number 2, Rx equals to 3. We divided equation number 2 by X, and we got that R equals to 3 over X. Then according to equation number 1, we know that 1 plus 2R equals to X squared. So we can substitute R in equation number 1 by 3 over X, because R equals to 3 over X according to equation number 2. So we subtracted, we substituted R by 3 over X in equation number 1, and we got that 1 plus 2 times 3 over X equals to X squared. 3 times 2 equals to 6. So in total we got that 1 plus 6 over X equals to X squared. Here we multiplied the equation number 1 by X, and we got that X plus 6 equals to X cubed. Then we subtracted X and 6 from equation number 1, and we got that X cubed minus X minus 6 equals to 0. Then we subtracted from equation number 1 2x squared, and then we added to equation number 1 2x squared minus 2x squared plus 2x squared equals to 0. So we changed nothing. Therefore, this operation is allowable because we add 0 to the equation number 1. So x squared minus 2x squared plus 2x squared minus x minus 6 equals to 0. Then we also know that minus x equals to minus 4x plus 3x. So we can substitute minus x by minus 4x plus 3x in equation number 1. So we substituted minus x by minus 4x plus 3x in equation number 1, and we got this expression. And then here we took a common factor from those two expressions. We took a common factor x squared, and inside the brackets we have x minus 2. And from those two expressions we took a common factor of 2x, and inside the brackets we have x minus 2. And from those two expressions we took a common factor of 3, and inside the brackets we have x minus 2. So in total we have here, we can take a common factor of x minus 2 out of equation number 1, this equation. So we took x minus 2 as a common factor of this expression, and inside the brackets we have x squared plus 2x plus 3 equals to 0. So this is a quadratic equation. Inside the brackets we have a quadratic equation. We have two solutions to these expressions. To equation number 2 we have two solutions. The first solution is that x minus 2, either x minus 2 equals to 0 or x squared plus 2x plus 3 equals to 0. Okay, this is solution number 1 and also solution number 2. So according to solution number 2, x squared plus 2x plus 3 equals to 0. This is a quadratic equation, and the general formula for a quadratic equation is ax squared plus 6 plus bx plus c equals to 0, when a, b, c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we found out the value of x according to a special formula. This special formula, x equals to minus b and plus minus square root of b squared minus 4 times ac over 2a, and actually inside what we have inside the root is the discriminant of x, and if the discriminant is negative, then there is no solution to the equation, to the quadratic equation. So if we will find that the discriminant that equals to b squared minus 4 times ac, if it is negative, then there is no solution. So this possibility is not correct. So we found out that the discriminant of our specific quadratic equation, that is to say, the discriminant is b squared minus 4 times ac, and that a in the quadratic equation x squared plus 2x plus 3 equals to 0. In this quadratic equation, a equals to 1, b equals to 2, and 3 equals to a equals to 1, b equals to 2, and c equals to 3. So therefore b squared minus 4 times ac is b squared is b is 2, so b squared is 2 squared, 2 squared is 4, and 4 times ac, 4 times a is 1, 4 times 1 is 4, and c is 3, so 4 times 3 is 12, and 4 minus 12 is minus 8. So we found out that this discriminant equals to minus 8, that is a negative number. Therefore, there is no solution to this quadratic equation. Therefore, this possibility is not correct, and we left only with the possibility that x minus 2 equals to 0. So if x minus 2 equals to 0, then x equals to 2. So we found that x equals to 2, and we have equation number 1 that states that r times x equals to 3. So we can substitute x in equation number 1, this equation, by 2, because x equals to 2, and so we substituted x by 2, and we got that r times 2 equals to 3. We divided equation number 1 by 2, and we found out that the radius of the semicircle equals to 3 over 2 units, or in terms of numbers, the radius of the semicircle equals to 1.5 units. I will repeat again, the radius of this semicircle equals to either 3 over 2 units, or it is, we can also express it as 1.5. The radius of this semicircle will be also equal to 1.5 units, or 3 over 2 units. Okay? Thank you very much.